Today's lesson is on geometric mean. So geometric mean is a special type of proportion that we are going to learn about, and we're going to see how this relates to right triangles, how it creates similar right triangles. So let's get started. The geometric mean of two positive numbers a and b is the positive number x that satisfies a over x equals x over b. So in this proportion, we would say x is the geometric mean of a and b. Okay? Now, some people like to remember and use different formulas. So they'll say x squared equals a times b, or x equals the square root of a times b. Those are all correct, but I like to use this proportion every single time to stay consistent. So that's how I'm going to be teaching it in today's lesson. Okay, so again, x here would be the geometric mean of a and b. So let's just look at some basic problems with finding geometric mean and using this proportion. So number 1 says find the geometric mean between 4 and 8. So I would take 4 over x equals x over 8. So when I cross multiply, I'm going to get x squared equals 32. Take the square root of both sides, and x is going to equal the square root of 32. If I simplify that, I can simplify the square root of 32 as the square root of 16 times the square root of 2, so x equals 4 root 2. Okay, so that would be the geometric mean between 4 and 8. Now, number 2 says the geometric mean between 5 and x is 10. We want to find the value of x. So now we're given the geometric mean, we know one of the numbers, and we want to find the other. So this one's going to be set up if I use the proportion 5 over my geometric mean, which is 10, equals 10 over x. So I'm going to cross multiply. I get 5x equals 100, so x equals 20. Okay, so we could say the geometric mean between 5 and 20 is 10. Okay? Now, how does this connect to geometry? Okay? In right triangles, okay, if we draw an altitude from the right triangle down to the hypotenuse, all right, it is going to create 3 similar triangles. Okay? So, if I have this triangle WXZ, all right, this triangle, notice I'm going from WXZ, so I'm starting at my right angle, I'm going down my long leg to my hypotenuse, okay? This triangle is going to be similar to, all right, let's start with the larger of the 2 right triangles that are formed, okay? I'm going to start at my right angle. I'm going to go to the long leg down to the hypotenuse, okay? So that's going to be triangle YXW. Okay, so that big triangle WXZ is similar to triangle YXW. Now, if I look at the smaller of the 2 right triangles that are formed by that altitude, again, let's keep this blue. I'm going to start at my right angle, okay, so that's points Y, go to my long leg down to my hypotenuse. So that is similar to triangle YWZ, okay? So we're just practicing right now identifying those similar right triangles, okay? So for numbers 3 and 4, we want to write a similarity statement for the 3 right triangles below. Remember, the order matters here. So for each of these, when I was looking at that right triangle, I started at my right angle, then I went down the long leg to the hypotenuse. All right, I do that every single time so that I stay consistent in how I'm going to write my triangles. Okay. So for number 3, all right, I'm going to start with the largest right triangle. So my big right triangle here is triangle ABC. Okay. Now I'm going to write my similarity statement. So I'm going to start at my right angle, all right, which is at letter B, go to my long leg, down my hypotenuse. So triangle BAC is similar to, now I'm going to look at this first triangle here. Okay, start at my right angle D, long leg to the hypotenuse. So triangle BAC is similar to triangle DAB, which is going to be similar to, if I look at that second triangle, start at my right angle, go to the long leg, down to the hypotenuse. So triangle DBC. Okay? All right. And we're gonna see on the next page how this relates to geometric mean. Okay? With number 4, all right, looking at that big right triangle, I have triangle STR is similar to, all right, I'm going to look at my first triangle here. Remember, I'm going from starting at the right angle, going from the long leg down to the hypotenuse. So that's going to be similar to triangle UTS, which is similar to triangle USR. Okay. Now, if you wanted to say triangle RTS is similar to triangle STU, which is similar to triangle RSU, that would also be correct. Okay, so the order does matter. You don't have to stick with that same order that I do. I just like to be consistent where I start at the right angle, I go from the long leg to the hypotenuse, and I remember to do that every time. Okay? Now, when we see similar figures, we should be thinking about proportions, okay? So in our last unit, we learned that similar figures, the sides were proportional, okay? This is where this geometric mean comes in, all right? So in this right triangle, the altitude from the right angle to the hypotenuse divides this hypotenuse into 2 segments, okay? This is where we have those 3 similar triangles, those 3 similar right triangles, all right? The whole hypotenuse is going to be C, and we're going to break that up into this segment here, which I'm labeling A, and this segment here, which I'm labeling B. Okay, the ratios, all right, or the proportions that I can set up here, okay, if I just compare the 2 triangles on the inside, okay, if I look at this side here, okay, that's going to be my smaller leg, okay, so the relationship between my small leg to my long leg, all right, is going to be proportional to, if I'm looking at the larger triangle inside, my small leg over my long leg, okay? So I'm just setting up a proportion here. If I set that up, my proportion is going to be A over Y, which equals Y over B. Right? And right now when I write this proportion, I can see that Y is the geometric mean of A and B, okay? This is that geometric mean proportion that we talked about. Okay, so that's our geometric mean. That's the altitude theorem, okay? Because we're using the geometric mean here, this Y is the altitude of the right triangle, right? Now, we also have geometric mean relationships with, if I'm looking at this big right triangle, with its 2 legs. Okay, so let's look at this first one here. If I'm looking at this small right triangle on the left side and my whole right triangle here, okay, this is the short leg, over my hypotenuse. Okay, so if I write that out, that's A over X. And then if I'm looking at my big right triangle, okay, my small or my short leg is X over the hypotenuse, which is that length C. So that's going to be equal to X over C. And again, I see I have that geometric mean proportion where X is going to be the geometric mean between A and C. So I have a short leg over the hypotenuse is equal to my short leg over my hypotenuse. All right. I can do the same thing with the larger right triangle inside. Okay, so if I look over here, all right, B is the long leg over the long leg over the hypotenuse is equal to my long leg over my hypotenuse. So B over Z equals Z over C. All right, so now I can see that Z is the geometric mean between B and C. Right? So when we take a right triangle and we draw an altitude from that right angle down to the hypotenuse, all right, it creates these three different geometric mean proportions. The first one has to do with the altitude. So A over Y equals Y over B. And then our other two have to do with the leg of that larger right triangle. Okay? So we're going to practice using these geometric mean proportions to solve for sides of these similar right triangle diagrams. So if I look at number 5, okay, for all of these, I think one of the trickier things to do is to determine which of these proportions you're going to have to use, okay? So let's, before we get into this, talk about how we're going to decide that. All right? If you are either given the altitude or you need to find the altitude, you're going to use this first proportion, okay? If you are given one of these legs or you need to find one of these legs, then you're going to use one of those leg theorems, okay? So if I look at number 5, all right, I want to check to see if I'm given an altitude or a leg. All right, it's clear right here that I'm given the altitude, all right, of the larger right triangle, okay? So I'm going to use this first theorem here, all right? So 5 over X equals X over 8. All right, so 5 over X equals X over 8. All right, cross multiply, I'm going to get X squared equals 40. Take the square root of both sides, and X equals the square root of 40, which would simplify to 2 root 10. Okay, because I can break that up into the square root of 4 and the square root of 10. Okay, so again, my short leg over the long leg equals the long leg, the short leg over the long leg equals the short leg over the long leg. All right. Now, number 6, if I'm looking at the large right triangle, all right, I look at that altitude. I am not given the altitude, and I'm not trying to find the altitude. All right, if I look at this triangle, I am trying to find one of those legs, okay? So I have this piece of my hypotenuse over the leg equals the leg over the whole hypotenuse. So this whole hypotenuse here is 14 plus 6, which is 20. All right, so when I set up my proportion, I'm going to have that parts of my hypotenuse, so 6 over x equals x over the whole hypotenuse, which is 20. All right, cross multiply, and I'm going to have x squared equals 120. So x is the square root of 120, and x is going to equal, right, I can break this up into the square root of 4 times the square root of 30. So 2 times the square root of 30. Okay? All right, let's try some more. Okay, so for number 7, I want to decide which one of these theorems I'm going to use. So I look at my large right triangle. All right, I'm not given, or I'm not trying to find the altitude, right? So I have the leg, right? Now, if you have the leg, you still are going to use that leg theorem. All right, so with that leg theorem, it's part of your hypotenuse, right? So that's going to be my x over the leg, which is 6, equals 6 over that whole hypotenuse, which is 12. Okay, now what's nice about this one is when I go to cross multiply, I'm not going to get an x squared. I'm just going to get 12x equals 36. All right, so I just have to divide both sides by 12 to get x equals 3. Okay, so you're not always going to get that x squared. You're always going to have, right, the same number or variable here. All right, but if it's not, oops, I don't know what I just did there. All right, if it's not a variable, you're not going to have that x squared that you have to deal with. Okay, so number 8, look at that right triangle. All right, I am given the altitude. So if I'm given the altitude, all right, I'm going to use this first theorem here. Okay, it's that piece of your hypotenuse over the altitude equals the altitude over that other piece of the hypotenuse. Okay, so that's going to be x over 12 equals 12 over, now this is x plus 5, so I'm going to be really careful and put that in parentheses. All right, so I don't forget to distribute when I cross multiply. All right, so I'm going to have 8 times x plus 5 equals 144. And I'm going to solve. All right, divide both sides by 8, and x equals 13. Okay. All right. Moving along to number 9. All right, I check to see, do I have the altitude? Nope. I am given one of the legs, so I'm going to use my leg theorem. All right, so part of my hypotenuse over that leg equals the leg over that whole hypotenuse. All right, so 5 over 9 equals 9 over x. And when we go to solve here, x equals 16.2. Okay. All right, number 10. All right, I look at that whole right triangle. I am given the altitude. All right, so I'm going to use that altitude theorem there. All right, so 9 over x equals x over 20. Okay, and if you do what I'm doing here, where you highlight either the altitude or the leg, all right, that, whatever you're highlighting, that's going to be the geometric mean. All right, that's what's going to show up twice there. All right, so when I cross multiply, I have x squared equals 180. So x equals the square root of 180. And I can break up the square root of 180 into the square root of 36 times the square root of 5. So I'm going to get 6 times the square root of 5. Okay. For number 11, all right, this is another one where I always look for the altitude first. I have my altitude, all right, that's going to be my geometric mean. So my piece over the altitude equals the altitude over that other piece. So 16 over 10 equals 10 over x. All right, so 16x equals 100. Divide both sides by 16, and x equals 6.25. Okay. And in our last example, I don't have that altitude. I look, all right, I'm trying to find one of those legs. All right, so my piece of the hypotenuse over my leg equals my leg over the whole hypotenuse. So 22 plus 10 is going to be 32. All right, so again, piece of my hypotenuse over that leg equals that leg over the whole hypotenuse. And we're going to get x squared equals 704. All right, now this is a bigger number we want to find a perfect square for. All right, so x equals the square root of 704, and 64 is one of my factors of 704. So I can write this as the square root of 74 times 11, and x equals 8 times the square root of 11. Okay? All right, so that's pretty much it with geometric mean. It is kind of a tricky topic, so if you need to watch this video more than once, you can do that. And if you have any questions, you can comment below. Otherwise, thank you so much for watching.